Hi everyone. Today we're going to study representing relations using matrices. A relation between finite sets can be represented using a matrix with elements 1 or 0. Suppose that R is a relation from set A with elements A sub 1, A sub 2 up to A sub n, to set B with elements B sub 1, B sub 2 up to B sub n. The elements of A and B have been listed in a particular but arbitrary order. When A equals B, we use the same order of elements for both the sets. The relation R can be represented by the matrix M sub R with elements small m sub ij, such that m sub ij equals 1 if the ordered pair A sub I, comma, B sub j is an element of the relation R, or the value is 0 if the ordered pair A sub I, B sub j is not an element of R. Let us see example 1. Suppose that set A equals 1, 2, and 3, and set B equals 1 and 2. Let R be the relation from A to B containing the ordered pairs of the form A, B, if A is greater than B. Write the matrix corresponding to the relation R. Set A has 3 elements while set B has 2 elements. Thus, the M sub R must be 3 by 2 matrix. We can write a blank matrix in here. Let us now write the respective ordered pairs. Starting with the first element of A, which is 1, we will take this as the A, while the elements of set B to be the variable B. So we have here 1, 1 and 1, 2. With respect to the condition that A must be greater than B, for the 1, 1, we see that 1 is equal to 1, so here we write 0. For the 1, 2, 1 is less than 2, so we write here 0. For the next ordered pairs, we use the second element of A, which is 2. So the ordered pairs are 2, 1 and 2, 2. For 2, 1, 2 is greater than 1, so we write here 1. For 2, 2, they are equal, so we write here 0. For the next ordered pair, we will use the next element of set A, which is 3. The ordered pairs corresponding to this will be 3, 1 and 3, 2. We can see in 3, 1 that 3 is greater than 1, so we write here 1. In 3, 2, 3 is greater than 2, so we write here 1. This is now the matrix corresponding to the relation. This is the final answer. Example 2. Suppose that set A equals A sub 1, A sub 2, and A sub 3, and set B equals B sub 1, B sub 2, B sub 3, B sub 4, and B sub 5. Write the relation R as a set of ordered pairs whose matrix is given by the matrix here. For our solution, we shall write the corresponding ordered pairs with one value on the matrix. The ordered pairs are here. For the first row, this number 1 here corresponds to a sub 1, b sub 2. In the second row, this number 1 corresponds to a sub 2, b sub 1. Another number 1 is here that corresponds to a sub 2, b sub 3. This number 1 corresponds to a sub 2, b sub 4. In the third row, this number 1 corresponds to a sub 3, b sub 1. This number 1 here corresponds to a sub 3, b sub 3. And this number 1 is a sub 3, b sub 5. This is the final answer. There are notes here that we need to consider. Number 1, if the diagonal elements of M sub r with elements a sub ij are all equal to 1, then the relation R is reflexive. Second, if M sub r equals the transpose of M sub r, then R is symmetric. Third, this M sub r union S equals M sub r or M sub S, or this is also called the join of the two matrices. Number 4, the M of R intersect S. This is equal to M sub R and M sub S. This symbol is also called the meet of the matrices. Number 5, the matrix of R composition S. This is equal to M sub R Boolean product with M sub S. Number 6, the M sub R raised to n is equal to the matrix M sub R, and this matrix is raised to n power. Number 7, the M sub R inverse is equal to the transpose of M sub R. Number 8, the M sub R complement equals 0 if A sub ij equals 1, or the value is 1 if A sub ij equals 0, obtained from the M sub R. I hope you learned something from this video. See you again next time.